Good evening, everybody. We're looking for an ordered triple of positive integers to satisfy this equation. Now, if any of you just looked at the thumbnail, probably would recognize that this identity right here is a very natural try to get started on this. It's kind of a tough problem, in my opinion, unless you have some sort of algebraic structure to work with like this. Now, this result right here is fairly famous. It's a unit fraction, or maybe the Egyptian fraction. Some of you guys have seen that. But notice that if you don't see why this is true right off the bat, you can just rewrite this as I'm just doing the right hand side here, a times the product of a and a plus 1. Okay, that's all I did right here, folks, to create the common denominator that you see kind of by default over here on the right. Now let me extend this bar just so I won't have to write too much here. So you still just have plus 1, right? Because this is already over a times a plus 1, right? But you can see that this a plus 1 factor cancels this a plus 1 factor, and you get 1 over a. And this gets used quite a bit, I think, in these telescoping sorts of problems, like in calculus settings, I think sometimes where you have a bunch of canceling terms. But in any event, this turns out to be quite handy, because what we're going to do here as we move along is note that you can use this identity to get this result right here. 1 over 29 is equal to 1 over 30 plus 1 over 870, and that's just a direct substitute. If you take a to be 29 right here, this becomes 30, and then you would have 29 times 30, which is the 870 you see here. Now notice that this is just 2 fractions, okay? We're trying to get 3 fractions, so we just have 2 so far. Now, but what we can do to make things more like what we start with is multiply through by 3. Okay, y'all, I multiplied this whole object by 3 to get 3 over 29 is equal to this, but it still looks like, well, what are we going to do? Because you need 3 of summands on the right-hand side. So you can actually reapply that same identity, rinse and repeat. We'll use 1/10, and you see 1/10 will get replaced by, you can see it right here, what do we have? We have 1/10 will get replaced by 1/11 plus 1 over 110. You see what happened there, folks? Again, the 1 over 290 stayed, okay? So we use that identity twice to get something that puts us in a position to solve this. Now, remember what do we have here? Now, y'all, what I did here, let me just come down here and I'll show you why I did what I did. You probably can already see it. But you see, I just made this a fraction that was equivalent to 1 over 110, except it had the 2 that we're looking for, right? And similarly right here, 5 times 290 is 1450, right? So you see we get the 2 and the 5 out of this kind of by just doing some very basic arithmetic here. You multiply top and bottom by 2, top and bottom by 5, and you get what you're looking for. So you see right off that one solution would be, what do we need? 11, 220, and 1450. Remember, we're to find the K, M, and N that meets this condition. So this is one possibility, and that's the answer. We can go ahead and circle it and say that's the answer, because the instructions just say find a solution. It didn't say find all solutions or anything like that. And I'm not even sure how to find all solutions on something like this, really, or know when I'm even done, you know. But but notice though, this wouldn't be the only possibility. You could actually, if you wanted to divide 220 by 5, right? Let's see, would that work out? I think you can get another solution here, folks. You can go through that on your own. It's not too hard to get another solution, I don't think, right? 220 works. But what if we wanted to divide, by the way, this is the answer I'm going to report to you. But I'm just saying, I think that there is another one, right? Because we can we can compare here. We have 2 over m down here, right? Now, what if we wanted, what do we need? 5, we did 2 on 220. What if we wanted to do 5? Okay, so wouldn't that be 5 goes into 220, what, 44 times? Okay, so wouldn't you have 5 over, oh God, I can't even do the arithmetic this late at night. But you can do another one, I think, folks. But anyway, I'll report this as the solution. And sorry, I'm getting a little tired, but I think you can get one more from this structure that we have. I'm just kind of brain dead. It's been a long day. All right, this is the solution I'm reporting, and I believe there's another. It's not too hard. I'm just literally about ready to go to sleep. Okay, thanks for viewing.